first mini lecture for section 2.1 of the syllabus, which corresponds to section 4.1 of the textbook. For the time being, we're skipping chapter 3 of the textbook because it covers numeration systems, which are about how to write the numbers and how to use those ways of writing the numbers to do computations. Right now, I'd like to continue with just the pure mathematics, so to speak, and continue our discussion from the last section, which was about division. So section 4.1 of the textbook is about divisibility. We'll begin with the very important definition. If a and b are whole numbers with b not equal to 0, then b is said to divide a if there's a whole number c, so that a is equal to b times c. We also say that b is a divisor or a factor of a, and that a is a multiple of b. More simply put, b is a divisor of a if a is equal to b times something. Okay, this is a really important definition to understand. And I say that because I very frequently hear students get the words divisor and multiple mixed up. But if you're going to be teaching, of course, it's very important that you use them in the correct way. So let's look at an example. For example, 28 is equal to 7 times something. Or, more specifically, 28 is equal to 7 times 4. So here are some things we can say. We can say 7 divides 28. We can say 7 is a divisor of 28. We can say that 7 is a factor of 28. We could say that 28 is a multiple of 7. And finally, we could say that 28 is divisible by 7. Okay, these all mean the same thing. They all mean that 28 is equal to 7 times something. So this is, like I said, this is an important definition to understand. And it's something that you're likely to see on an exam. So make sure you know how to spell this out. If I ask you, what does it mean for 7 to be a divisor of 28? You should not answer by saying it means that 7 is a factor or that 28 is a multiple or whatever. You should say it means that 28 is equal to 7 times something. 7 times c for some c. However you want to put that. These all mean precisely this. Okay, what I often hear people say is things like 28 is a divisor of 7, or 7 is a multiple of 28. So make sure not to get those words backwards. Okay. So for example, the divisors of 12 are 1, 2, 3, 4, 6, and 12. There are 6 ways to write 12 as a product of 2 numbers. Okay, so you can call these the factor pairs. You have 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. So we can draw each factor pair as an array. Let's do that. We have 1 times 12. That's just a 1 by 12 line. And then 2 by 6. 3 by 4. And we have 4 by 3. Six by 2. And 12 by 1. And so I point out that the middle factor pairs are the most square-like. So that would be those factor pairs, or these two right here. See, they're the closest to being a square. Yeah, that'll come up later. Now, notice, by the way, that we could have used arrays to find the factor pairs. So, for example, if you were working with like a 5-year-old, let's say, who knew how to count, maybe up to 20, let's say, and they could count pretty well. If you tell them to try to line things up, they can do that. You could have had them find these factor pairs by telling them, okay, first count out 12 blocks or whatever, and then try to make rectangles out of the blocks. How could we do that? You do a couple examples with them, and they'll get the idea, and then they can reliably find all the factor pairs. And that's before having learned about addition or subtraction or multiplication or any of that. Okay, they don't know any number facts. All they know is how to count and how to line things up in lines. And they could find factor pairs. Now, larger numbers require something more. So you're not going to be able to use arrays for something like the number 60. That would take forever. So instead, let's make what's called a rainbow diagram. And I just list the factor pairs like this. We'll begin with 1 times 60. Now you connect them with the little band. That's the rainbow. And then, okay, the number 2 is a divisor of 60. We have 2 times 30. Trying to leave myself plenty of space here. And 3 is a factor. There's 3 times 20. A 4 is a factor. 4 times 15. A 5 is a factor. 5 times 12. 6 is a factor. 6 times 10. Now, here's the question. Are we done at this point? Hopefully, because we ran out of space. So let's think about it. Well, I can check 7, and that's not a factor, and neither is 8 or 9. So I can check those by hand. Then I get to the number 10. And now 10 is already on the rainbow, but it's on the other side. And so I know I've checked everything up to 10. The question remains if there's any factors I haven't checked up in this area. Yeah, that would be on the other side of the rainbow. Well, think about that. Is that possible? For instance, is there a factor somewhere between, 20 and 30? How do I know there's not? Well, if there was, the other factor in that factor pair would have to be between 2 and 3, because 2 matches with 30 and 3 matches with 20. Okay, but I know there's not anything in here because I've checked everything down here. So what I'm saying is that once you get to the first number on the other side of the rainbow, you know that you're done. Because if you hadn't missed any factors up here, you would know you'd be missing factors down here. But we would know that that's not the case at that point. All right, well, let's try to do the same for the number 36. So we have 1 times 36. . 2 times 18. Three times 12. Four times 9. Okay, test 5. 5 is not a factor, so I skip that. And then I have 6. I have 6 times 6. And since the 6 would kind of be on both sides of the rainbow, what I'm going to do is just put a 6 in the middle and just draw a line to itself. And I know that since I got to the other side of the rainbow now, I'm done. There are no factors up here that I've missed. So these are all the factors of 36.